Hello dear children and welcome to the class of physics. We are discussing chapter number 12, electricity, and in the previous video lesson we discussed about resistance of an electrical circuit. We also discussed that this resistance depends upon certain factors. In today's video lesson we are going to discuss about the methods in which we can connect two or more resistors in an electrical circuit. But before we proceed with today's discussion, I would like all of you to have a look at this small story. Say there is a rock show in the city and the ticket for the rock show is rupees 200 for each person. So there is a committee of 3 people who will collect the ticket money from the people who are interested in attending this rock show. One of the members of the committee suggested that we will keep the counters in this manner, 3 counters one after the other, and every person who is entering inside the stadium will pay rupees 200 at every counter. So each person will pay 600 and enter into the stadium. The other member of the committee suggested that we can keep the 3 counters in this manner, and each person who is entering through each counter will pay 600 rupee and enter inside the stadium. Now dear children, I want all of you to take a moment and think about which one will be better. Obviously, without a doubt, you will make out that case 2 or the second possibility is proper for entering the people into the stadium, because in the second case there is no bottleneck, there is no traffic jam, there is smooth way of people entering into the stadium because there is less resistance. Whereas in case 1, because there is only one way and 3 counters are there on that particular way, there is more resistance in this case and there is more possibility that the traffic is very slow. Just as these counters placed in these examples, case 1 and case 2, we connect resistors in an electrical circuit so as to increase or decrease the overall resistance of the circuit. Have a look at this figure wherein 4 resistors are connected one after the other. I can also say that these resistors are connected end to end. So when we connect resistors in this manner, they are said to be connected in series. Now when the resistors are connected one below the other between the 2 common points, they are said to be connected in parallel. There is other way also to connect the resistors in parallel. We can connect the resistors in this manner, one after the other, but between 2 common points. In this case, they are said to be connected in parallel. So have a look at this figure. This is the first case of our example wherein the 3 counters are placed one after the other, and it resembles the resistors in series wherein the resistance is very high. And this particular figure resembles case 2 of our example wherein 3 counters are placed separately one below the other, and so there is proper way of the flow of traffic, and so there is a smooth entry into the stadium, and this resembles the resistors in parallel, and in this case we say that there is low resistance. In today's session we are going to discuss the resistors connected in series, and our topic for today's session is system of resistors. So our first method is when the resistors are connected in series. So have a look at the simple circuit diagram wherein the resistors are said to be connected in series. Just now I said that when the resistors are connected one after the other, or when they are connected end to end, they are said to be connected in series. Let's complete this circuit diagram. So we will draw a battery first here, and this is the positive and negative terminal of the battery. After the battery, we will connect a plug key and after the plug key we will connect an ammeter here. And as I told you that ammeter is always connected in series with the circuit, so you can make out that the positive of the ammeter is connected to positive of the battery. That is what we say that ammeter is in series with the circuit. We will name these three resistors as R1, R2 and R3. Can you guess what is left in an electrical circuit? The thing which we have to mark without fail is the direction of flow of electric current. It is always from the positive terminal of the battery to the negative terminal of the battery. So this is a simple circuit wherein three resistors are connected in an electrical circuit. But to understand that when we connect the resistors in an electrical circuit in series, how it affects an electrical circuit, what is the change in electric current, and what is the change in the total potential difference of an electrical circuit, let's understand this with the help of one small activity. So just now I told you that we have taken three resistors connected in series like this, and it's a simple circuit which we are using to perform the activity. So when you plug in the key, the current will start flowing through the circuit. Alright, now what we will do, we will connect an ammeter between the two resistors R1 and R2 and measure the current in an ammeter. Then we will connect another ammeter between the resistor R2 and R3 and measure electric current in that ammeter. You will observe that wherever you connect the ammeter in an electrical circuit, when the resistors are connected in series, the current flowing through the circuit remains the same. The current remains constant because current is flowing only through one branch. There is only one way of current to flow through the circuit. So when the resistors are connected in series, the electric current flowing through the circuit is constant. So now what we will do? We will connect a voltmeter between the two ends, that is at the start point of resistor R1 and at the end point of resistor R3. Alright, so these 2 points, you can see these two red dots, these are the two red dots wherein we have connected the voltmeter. Then we will plug in the key and we will measure the potential difference across the series combination of three resistors. Alright, so let us consider that potential difference is V volt. We got some potential difference between the 2 points and we wrote that potential difference as V. Once we note this potential difference, what will we do? We will take out the plug key, we will remove this connection of voltmeter, and now separately 3 voltmeters we will connect across every resistor like this. So across R1, R2 and R3 we have connected 3 voltmeters. Now we'll plug in the key and measure the potential difference across every resistor. So let's conclude that the potential difference across R1 is V1, across R2 is V2 and across R3 is V3. So we will observe that this potential difference is different. Across every resistor, the potential difference is different. But if you add these 3 potential differences across every resistor, it is equal to the total potential difference across the combination of the 3 resistors. So we conclude that V is equal to V1 plus V2 plus V3. So when the resistors are connected in series, the current flowing through every resistor is constant, it is the same, but the potential difference across every resistor is different. Now, if you measure the current, as I said, the current through any branch of the circuit remains constant. Now what we will do, we will find out one resistor whose value is equivalent to the 3 resistors connected in series. I do not want to connect these 3 resistors like this. Instead, I want to use only one resistor and I want to find out what should be the value of that resistor which is equal to the combination of these 3 resistors connected in series. But I don't know the value of that resistor. I don't know what is that R is equal to. So by using Ohm's law, I can make use of the formula V is equal to IR. V is the potential difference of the entire circuit, the battery which we have connected. The current flowing through the circuit remains the same. I can find out the value of R. But this R is for the whole circuit. This V is equal to IR is applicable for the entire circuit. Now what will I do? I'll try to find out the potential difference across every resistor. So for the first case wherein the resistor is R1, potential difference across R1 is V1, but the current flowing through that is I. It is same everywhere. So I can apply Ohm's law to the first resistor. So it is V1 is equal to IR1. Similarly, we can apply Ohm's law to the second combination of R2 and V2 and the third combination R3 and V3. So we will have V2 is equal to IR2, V3 is equal to IR3. We've got the value of V1, V2 and V3. We will substitute these values in the first equation. Our first equation is V is equal to V1 plus V2 plus V3. We will substitute the values of V, V1, V2 and V3 in this. So what we get? IR is equal to IR1 plus IR2 plus IR3. If you divide this equation throughout by I, we can cancel this I. So what we are left with? We are left with R is equal to R1 plus R2 plus R3. So the equivalent resistance of the 3 resistors connected in series is equal to the sum of the 3 resistors connected in series. So if I want to make use of only one resistor whose value is equal to the combination of these 3 resistors connected in series, what I'll have to do? I'll have to add these 3 resistors and its value will give me the equivalent resistance of this circuit. Since the resistors are connected in series, we write RS is equal to R1 plus R2 plus R3. So this is how we derive an equation, and this is an interesting and very important equation of your lesson. Alright, so let's now quickly review what we have learned today. That in an electrical circuit consisting of only one resistor, the current flowing through every branch of the circuit remains constant. When you add on resistors in the electrical circuit in series, the overall resistance of this circuit increases. When the resistors are connected in series, the current flowing through the circuit remains constant in every branch and it decreases. And the equivalent resistance of the resistors connected in series, if there are 3 resistors connected in series, its equivalent resistance is RS is equal to R1 plus R2 plus R3. And if there are n resistors connected in series, then the equation is RS is equal to R1 plus R2 plus R3 plus so on up to nth resistor. So this is the very important bottom line for today's session, that when the resistors are connected in an electrical circuit, the overall resistance of the circuit increases and the current flowing through the circuit decreases. Alright, with this we have a small assignment to do. Please try writing these two questions in your notebook. Question number 1 is, draw a schematic diagram of an electrical circuit consists of a battery of 2 cells, each of 1.5 volts, 5 ohm, 10 ohm and 15 ohm resistors and plug key, and all connected in series. Now you have learnt the method to draw an electrical circuit. You have to make use of the rules which we have studied and draw an electrical circuit. Second question is based on what we have learned in the earlier sessions, that you have to state the Ohm's law. You have to draw a schematic diagram to verify this law in the laboratory. And if you draw a graph between potential difference and current flowing through metallic conductor, what kind of curve will you get? And explain how would you use this graph to determine the resistance of the conductor. Children, both the questions have come in the exam of previous year. So please write down in the notebook and check your answer. So see you all in the next video lesson with new topic. Till then, bye and take care.